Welcome you, one and all the students. So today, as a part of the continuity of dynamic programming problem, we are going to discuss about the new topic. So in the early class, what we discussed about the what is called the backward and forward recursive equations. Right. So one of the example based on the definitions and the introduction, we observe the talking about the for a given network obtaining the shortest routes, right? That is for each that is for a given network that can be break up into a small stages, and each stages we solve it based on the solution output. Then we can go for the next stage. So that is the procedure. Now again, the another application on the dynamic programming problem is nothing but the knapsack programming problem. So what is this knapsack programming problem? So think it about a soldier who want to carry only the limited item which will be utilized at the war field. So what the soldier is going to decide is going to carry only the necessary items that should be utilized at the place of war, right? So that he will get the maximum victory, right? So similarly, thinking about the cargo loading in a ship. So the ship having a maximum capacity, so a person can or the owner can utilize maximum number of the items that will be requirements for a going to loading in a ship, right? Not unnecessary things should be loaded. So in that situation, what item should be loaded so that we can take the maximum items to be transport from one place to another place. And one more example, if you think it about, in a jet, a pilot is going to carry a parachute or the necessary items at the time of emergency situation. He is having an emergency kit, so that kit will be going to utilize at the time of emergency case, right? So what the thing is, a particular a bag or a kit or a loading place, we have to going to load only the necessary items, right? So that you will get the maximum return, right? Generally speaking. So for soldier, you have to get the maximum victory. For the pilot, they have to get the maximum safe. For cargo loading, you will get the maximum profit. In that way, they can do it. So that is the things we are going to discuss now. Let's move to the a small introduction. So mathematical form of knapsack problem. So all the applications since this can be put it in the mathematical formats. So here we are going to denote the what the item that we are going to package in a bag. So that one denoted by the item I. So how many number of items you are going to carry, right? So that is denoted by Mi. Now for this each and every item, what is the revenue you are carrying from one place to another place? So what is the profits? What is the output, right? What is the merit? So like that one can think it. So in business sense, talking about for this item, what is the revenue, right? And what about their wage? That is also important things, right? So here for each item I, the corresponding weight is denoted by Wi and the revenue is denoted by Ri. So now we can try to form the general form. So naturally, the mathematical sense, if you form, we want to take like this, right? So the weight into the number of items, right? Product it, sum it up. That should be going maximum to a particular capacity of the bag or the cargo loading ship, whatever it is, right? So this is talking about the maximum. So this is the condition, basic condition. And naturally, the number of items should be a integer. It should be a only strictly greater than or equal to 0, right? It should not be a negative. So it is a basic things. And for this, we have to talk about the maximum output or revenue or profit, what are things. What here we are going to think it. It is talking about the revenue into the number of items. So for each and every items, what about their corresponding revenues? For example, for item 1, a particular number of item 1 you are going to carry. For that particular number of item 1, you are talking about their revenue. Like that, for each and every item, we are going to talk about their revenue, right, and sum it up. So that is nothing but our the function. So naturally, we have to expect it should be a maximus. So students, you should be very careful when you are go through the book. There is a small error, printing error. Sometimes instead of giving the maximize, they put it minimize. That's not a correct thing. So it is a maximise, right? Okay. Now this, once you have formulated the knapsack problem in the mathematical sense, then we can put it in little bit explicit sense. We consider the each and every item by the stages. Already we discussed in the introduction. Like that, here also we are talking the stages. So what is stages means? Ith stage means nothing but representing the ith item. And the thing Mi is what? Nothing but the number of items. So that is alternate stage of I represented by M. So what is this meaning? So I can maybe carry a particular item I, maybe 1 or 2 or 3 or whatever things. Therefore they use the word the alternative of stage I. Right? So instead of carrying one item, maybe I can take one or more. Right? So that is denoted by alternate of stage I represented by Mi. And the corresponding revenue returns. So revenue into corresponding number of items, that is denoted by Ri, Mi. And the maximum things we can pack it for a particular item I. It is denoted like this. That is the maximum load, capital W, over the particular item whose weight is denoted by Wi. So therefore, capital W over Wi. So that you will get the modulo. So that is the must be integer. It should not be a decimal form. That's why you will put it largest integer. It should be less than or equal to capital W by small Wi. And now we are going to talk about, for each and every stage, we are going to talk about the states, like a previous concept we have discussed. So here Xi denotes the states of stage I, and total weight assigned to the stage I or I plus 1 and so on here. Now we formulate these things in the little bit clear sense. What is that? Defining Fi of Xi. So what is this Fi of Xi? We are talking about the maximum returns of stage at the stage I. So therefore we put this is nothing but the maximum return. So therefore the recursive equation we can put like this. Fi of Xi can be expressed in terms of Fi of Xi plus 1. So more formally, Fi of Xi is nothing but, that is maximum return can be put like this. Maximum of Ri Mi, that is revenue to the particular number of items I, plus the next items Fi plus 1 of Xi plus 1. Right? So this one, provided the condition is what? At the stage of nth stage, we take it this is equal to 0. If I take I equal to n, so that must be assumed to be 0. So these are the important things. And further here the Mi is number of items I. So that will be going up to 0 to capital W over small Wi integers. And the state is denoted going up to capital W, maximum. Right? So once you will get the first step like this, then you can recursively you are going for the next steps. That is, instead of expressing fi of xi in terms of fi of xi plus 1, now I am going to modify this xi in terms of xi plus 1, or in other words, like this. That is, the ith state and I plus 1th state, their difference should be nothing but the weight into the number of items. Right? So, this is easily one can observe. Therefore, using this relation, we can rewrite the step 1 like this. Right? So there is no change. Only here I am going to change it. In the place of xi plus 1, I replace from here xi plus 1 is nothing but xi minus wi mi. So that is the things here. So no change from the previous step 1 and step 2. So only thing, this is the relation that we are going to modify here, apply it here. Right? So this is the general form, the mathematical form of Knapsack. Right? So I hope so. This introduction is maybe very clear. Right, let's, based on this introduction, let's start with an example. A 4-ton vessel, if you consider a 4-ton vessel, a ship, right? So it may be carrying maximum 4 ton. So that is the things here. It's loaded with one or more of 3 items. So considering 3 items, it may be 1 items or 2 items or 3 items, whatever things. Maybe like a car, maybe a bike, or maybe some food grains, like that. Different types of items you are going to load it in the vessel, right? So that is the thing. So the following table gives the unit weight Wi in tons. So here the weight denoted by the tons, not a kg, it's a tons format, right? So and the unit revenue in the thousands of dollars RI. So that is RI means what? RI thousands dollars, right? For item I. Maybe if you want, you can change it as a, this is instead of rupees also. That's not a problem, right? So how should the vessels be loaded to maximize the total return? So in which way that you are going to loading the items, the among these 3 items, you are going to load it, right? So that item should gives the maximum profit to the ship company, right? So that is the thing. So here the data is given like this. So the first item 1, their corresponding weight for each and every unit is 2 ton. That is the meaning here, and that will give the uh, revenue. So if you are carrying one item, that is item 1, whose weight is 2 ton. If you transport from one place to another place, then you will get $31. That is the meaning, right? So like that, you can take many number of items, right? So similarly the item 2, right, with 3 minutes. start with item 3, that is nothing but starting from the stage 3 onwards, right? So stage 3 onwards, I am going to taking this item 3 whose weight is 1 ton and the return is 40. So we are going to discuss. So these are the things. So since the weight Wi and the maximum weight capital W are integers, so that the xi must be integer. So this is an observation, because here we are considering the weight is the integer form only, and capital W must be a integer, right? That is 4 ton, right? So that is also integer. Therefore, naturally the state must be also defined in the integer sense form, right? It should not be in the decimal form, right? So I am using the backward recursive. I already recall it. So I am going from starting from stage 3 onwards. That is stage 3 denoted by x3, right? X3. So naturally this x3 must be what? Less than or equal to w divided by small w. So here I put it wrongly. So x3 is what? Less than or equal to capital W over small w. I, right? That is I equal to 3. So therefore, capital W is nothing but 4. That is the maximum capacity. So therefore, 4 divided by 1, that is 4. That is the things here I put it. And naturally, if it is less than or equal to 4 means what? I can consider I should not load the item 3. That is the meaning. In other words, there is no items carry in item 3 in the vessel. That is 0, right? So 0 should be considered, because maybe I cannot consider the item 3. That is 0. Maybe 1 item I can take, maybe 2 item I can take, maybe 3 item I can take, maybe 4 items I can take. That is the meaning. So all the possibilities here I will put it 0 to 4 hours, right? Now go for the recursive equation. So it is f3 of x3. Already we recall the formula, right? So fi of xi equal to maximum of, this is ri mi, right, plus fi plus 1 of xi plus 1. So this is the step 1. So therefore I put here I equal to 3. So if you put I equal to 3, then this is this is R1, R3, sorry, R3, M3. This is F3 plus 1, that is F4, X3 plus 1, that is X2. And M3 is clearly we here observe this much number of states, therefore M3 is going up to 4, and X3 is already we observe less than or equal to 4, right? And what is R1? From the table we can clearly observe that this R3, sorry, from the table the R3 is nothing but 14. So therefore we will put 14, right? And here this is F4 X4. We already observe F4 X4, it does not exist, right? That is F4 X4 does not exist. If you observe this case, here. So if I take n equal to 3 here, so that is F4 X4, this is 0, right? That is, this is the final stage, right? This is the final stage. Because I take n equal to 3 here, therefore F4 X4 is always 0. So that is the assumption. So therefore, the thing is what? I have to take this F4 X4 is 0. So therefore, simply it is 14 M3. Now we can put this in a table sense, right? All this value in the table form like this, right? That is X3 I'll put 0 to 4, right? And the formula 14M3, that is here I'll put it here 14M3. Now what are all the M3s? I have to consider 0, 1, 2, 3, 4, right? So therefore I'll put it M3 is 0, 1, 2, 3 and 4. Right? So here I'll substitute here 14 M3. So in the place of M3, if I go for M3 equal to 0, so here 14 into 0, I put 0 here. If I go here M3 equal to 1, what is this meaning? So you are at the state 0. 0 means what? You are not going to put any weight there. But here if you take M3 equal to 1, that is meaningless, right? That is, I am not considering any items here, right? That is item 3. I am not considering here. Then how should I take the item 3 with 1 unit? That is not possible. It is meaningless, right? That's why I'll put here dash. So similarly, here is the same condition, right? I'm not taking this the third items, right? But how should I put two number of third items? So that is meaningless. Therefore, I'll put that. So similarly, all the things are getting dashed, right? It is meaningless. Therefore, I put it. Now similarly at the case x3 equal to 1. So what is the meaning? I am going to load the item 3 1, right? 1, right? Now if I take m3 equal to 0, that is possible. Maybe I can take this as 0 number of items of i3, that is third items, right? So therefore 14 into 0, therefore 0, right? So similarly put m3 equal to 1 here, that is possible because here I am allowed for one item, therefore 14 into 1, so that is 14, right? Similarly m3 equal to 2, it is not possible because I am allowed only one item, but you are taking m3 equal to 2 items, so that is not possible, it is meaningless, therefore I'll put the dash. Similarly for m3 equal to 3, m3 equal to 4 also, right? So similarly going for the, you are considering two items of i3, right? I equal to 3, right? So that is all the possibles. Put m3 equal to 0, that is 14 into 0, and 14 into 1, and 14 into 2. Similarly here only I am allowing only two items, but you should not take carry the item three numbers, right? So that is not possible, therefore I'll put dash dash dash. So similarly, we calculate all these things. Right now, the thing is, I have to go for optimal solution. What is optimal means? I have to consider the maximum case. So now the thing is what, for this 0 x3 equal to 0, you think it about all these things. So here the maximum is 0 only, right? So therefore I'll put 0. So corresponding m3. So which one gives this 0? So this m3 equal to 0 gives the 0. Therefore this 0 I'll put it here. Similarly, among these, that is for x3 equal to 1, there are two values, one is 0 and the other is 14. So among these two, the maximum is 14. So that's why I'll put it. So this 14 will be used by m3 equal to 1, that is the optimum, therefore I put here 1. So similarly for 2, the three possibles, 0, 14, 28. So among these, the maximum is 28. Therefore, the 28 is given by m3 equal to 2. That is the things here. So similarly, I put all these things, right? Now, based on this, I have to move for the next stage. So here I give the reason, right? So before, based on this, we are moving for next stage. That is put I equal to 2, right? So previously I'll put I equal to 3. Now I equal to 2. That is fi xi equal to maximum, right? R2 m2 plus f2 plus 1. Here x2 plus 1, right? x2 plus 1. But what is x2 plus 1? x3. x3 can be expressed as what? xi minus wi mi, right? So put I equal to. So that is the, in the introduction we discussed that case. So therefore x3 can be replaced by x2 minus w2 m2. So that is the things here I'll put it, right? So as usual here I have to observe this m2 is no change, like m3 it is going maximum possible up to 4, therefore that one I'll put it. But x2 is what? It is going up to capital W divided by small w2, right? So what is w2? It is nothing but 3. You can refer the table in the question, right? So that is 4 over 3. So it is possibly 1 point something, right? So but we have to consider only integer, therefore I put 1, right? So that is the lower bound, right? So it is 1, right? Not lower bound, it's we should consider the integer, that's it. So very close to 1 point something is 1, therefore that is the thing. So x2 going up to 1. So what is the meaning? x2 taking from 0 to 1, in other words only integers, so x2 taking 0 and 1, right? So in this case, so again this can be reformed, right? Reformed, and here I'll put it, that is put w2 equal to 3 and remaining things I'll keep it, right? So now again putting the table format. So x2 going from 0 to 4, no problem, right? So this optimum function here I'll put it here, right? So m2 is taking only two possibilities, one is 0 and other one is, right, 0 and 1, because what, x2 taking only up to 0 and 1, right? So therefore I'll put 0 here, 1, m2 equal to 0, m2 equal to 1. So as usual you're taking for the second item, right, 0, right, taking the number of items, that item should be 0, then I'll put it here. So 47 into 0, so here 3 into 0, right? So therefore f3 of x2, here this is 0, so f3 of x2 is what? What is f3 of x2? So refer the previous stage, so that is nothing but So here maybe I can put it. So f3 of 0 is 0. From the previous table, you can observe that case. That is stage 3 that you can observe, right? So that is 0. So similarly, if I go for this case, if I take m2 equal to 1, that is x2 minus 3 into 1, that is minus 3. x2 minus 3 is not possible, right? It does not exist, right? Because here I am allowing only 0 items. Then how should I loading 47 m2 equal to 1? That is not possible. It is meaningless, like a previous explanation. This is not should be. This is not a meaningful sense. Therefore, I put dash. So similarly, I am going here put m2 equal to 0, and that is the for the case of x2 equal to 1, right? And here m2 equal to 0. Therefore, f3 of x2, right? So f3 of x2 for the case m2 equal to 0. So here I will put it here. Here I will put it x2 equal to 1. So therefore f3 of x2, that is 1. So f3 of 1. So f3 of 1 is from the previous table, it is observed that it is 40. You can observe it. Therefore that is the things here. So similarly this is meaningless. Similarly going for here, similarly all those things, right? Here you can acceptable because you are taking x2 equal to 3, then you can allow for m2 equal to 1, right? m2 equal to 1 is allowed. So therefore here I will put it. Here you can clearly observe, right? So this value does not exist, right? Okay. Now this is from the previous table. You will get all these values, right? Now the optimum solution. What is the things? Let me recall. So among these row, the optimum is 0. So that is given by m2 equal to 0. That is the things here. M2 asterisk is 0. Similarly, this 14 dash. So among these, the maximum is 14. So this 14 given by m2 equal to 0. That is the things here. Similarly here 28 and dash, among these the maximum is 28, and that is given by m2 equal to 0, that is the things here. Similarly here 42, 47, so among these the maximum is 47, that is here I will put it. The 47 given by m2 equal to, so that is the things here I put. So similarly 56 and 61, 61 is the maximum, right? So that is given by m2 equal to 1, that is the things here I put, right? So keep it in mind all these things. Now we have to move for the next stage 1, right? So stage 2, now we have to move for stage 1. So stage 1 as usual from the mathematical sense, here I have to put I equal to 1. So fi xi, that is I equal to 1, f1 x1 equal to maximum, right? So here m1 vary from 0 to 4, right? And 31 m1 because this is r1, right? So r1 m1, so r1 is 31. You refer the question. So that is the things. f2 of here x2. So what is x2? x2 is nothing but x1 minus r1 m1, right? So that is the things here I'll put it. w1, sorry, w1 m1. So that is the thing. So w1, you refer the table. So w1 is nothing but 210, right? So therefore I'll put it substitute, right? So again observe this x1 is bounded to 2, right? The reason is what? Capital W is 4 and small w1 is nothing but 2, right? So therefore 4 by 2 is nothing but 2. It is clearly integer, so therefore it is 2. So therefore x1 taking 0, 1, 2, right? 0, 1, 2. So based on this, we have to move for the next table. So that is the things here. I will put it everything. So because x1 varies from 0 to 2, right? So 0, 1, 2, all those things. I will put x1 0 to 4, right? Same similar argument. I will put it here, right? So m1 equal to 0, right? Put m1 equal to 0 here. You put m1 equal to 0 here, and put x1 equal to 0. Therefore f2 of 0, right? f2 of 0 from the previous table we can observe it is 0, right? So that is 0 plus 0, 0, and this is not possible because for m1 equal to 1, no such a things will be exist, right? For x1 equal to 0, because I am allowing only 0, but we are going for more than 0, it is not meaningful sense. Therefore, similarly for the same argument here, it is also not possible, right? So similarly, going for here, put m1 equal to 0 here, right? So 31 into 0 plus f2 of x1, x1 is nothing but 1 minus 2 into m1 is nothing but 0. So that is the things, that is f2 of 1. So f2 of 1 we can observe from the table, right? So it is nothing but 40. So that is the things here. So again this is not allowed, this is not meaningful way. So So similarly, you can keep on arguing the remaining entries. Now again going for optimum solution, I have to take the optimum on this row. So 0 is the only possible, therefore 0. So this 0 given by this m1 equal to 0, therefore I'll put here. Similarly, the same things here, argument here 14 dash dash dash. So 14 is the maximum, I'll put it, it is given by 0, that is the things here, put it. So here 28 and 31, among these 31 is the maximum, so it is given by m1 equal to 1, so that is the things here are reflected. And here 47, 45, the 47 is the maximum given by m1 equal to 0, so that is the things here reflected here. Similar case here 61, 59, 62, so 62 is the maximum given by m1 equal to 2, so that is the thing, right? And the stages are over, right? And we'll stop here, right? Because there is no stage I equal to 0, right? So we are staging from I equal to 1, 2, 3 onwards, right? That is backward forward. So therefore here we will stop it. Now from this argument we can conclude the solution. So how? Because we already observed that the maximum tons carried by the vessel is 4 tons, right? So that is capital W equal to 4 tons. From the stage 1 you can observe. So this is the stage 1. So here we can observe x1 equal to 4, right? X1 equal to 4. So that is this one. So this will give the maximum return 62, right? So step by step we can go. So which gives the m1 asterisk is 2, right? So that is here, this is the 2, m1 asterisk. So it is given by m1, right? So these are the things, m1, right? So m1 asterisk, that is nothing but 2, right? Now what is this meaning? So that is you are going to carry the item 1 2 units, right? So that is 2 items you are going to carry, that is item 1 2 units you are going to carry, right? It will be loaded on the vessel. Right now back substituting here, therefore going for x2, x2 is nothing but x1 minus 2 m1 asterisk, that is we are talking about the optimum, right? So therefore going for x2, right? X1 already 4, therefore I am going for now x2. So x2 is, how can I allocate it? That is next item, it is nothing but x1 minus already allocated, that should be subtracted. So how many things we are allocated for item 1 is, that is 2 units, right? And for this ith item, that is m1 item, so that is the things here. So how many things? That is 2, right? m1 asterisk is 2, so therefore m1 asterisk I will put 2. So therefore x1 already we know it, that is 4, therefore 4 minus 2 into 2, 0. So what is this meaning? There is not a possible to loading the item 2, right? So simply over once you are loaded the item x1, right? So therefore this is 0. Now again proceed further for stage 2. So x2 is 0, then I have to proceed for what is x3, right? So how do you calculate? X3 is nothing but x2 minus already what is the things we are observed from the concept. So this is minus w 2, that is nothing but 3, right? We already observed, just go through it. So m2 asterisk, right? So therefore m2 asterisk is 0 from the stage 2 table we can observe. So here I will paste it, and x2 is here, we'll observe it is 0, therefore 0 minus 3 into 0, that is 0. So again x3 also should totally omitted, right? Now from stage 3 we can observe, sorry, here, yeah, x3 equal to 0, right, from here. So which gives the x3 equal to 0 gives the optimum solution is m3 asterisk is 0. You can observe from the table, right? M3 asterisk is. So therefore the complete optimal solution what? So m3 asterisk is 0, m2 asterisk is 0, and m1 asterisk is 2, right? M1 asterisk is 2. So what this meaning? So this for corresponding m1 asterisk 2, taking $62,000, you are going to take it as a the main return, right? So just here you will observe it, right? So these are the things, right? M1 asterisk is nothing but 2, so that will give the maximum return $62,000, right? Because this is everything is put it in the figure 1000, so that's why we will put it $62,000, right? So the vessel can load the item 3 2 units only, not the remaining items considered, right? Only they are going to consider the item 3, right, with the 2 units, right? So that the company gets the maximum revenue $62,000. So this is the one of the nice example talking about the knapsack problem, right? So based on the same concept, you can refer the exercise, exercise number 2, the problem number 2. Here I'll give the only the solution, or just go through this very simple format they given. Easily you can observe from that the question number 2 of exercise, the stage 3, stage 2, and stage 1, and observe the maximum revenue, right? So here the maximum revenue is $120, and corresponding the M1 asterisk, and M2 asterisk, and M3 asterisk, everything's here. It is clearly given. So M1 asterisk something